Now that we've covered the model to predict these or evaluate the effectiveness of a defenseman, I'll be looking at which predictors can be used to evaluate the effectiveness or success of a goaltender. So most often the main statistic that's used when evaluating a goaltender's performance is their save percentage, which is simply the percentage of all shots on goal that have been saved by that goalie. So I decided to run a regression with the save percentage set as a response to see which predictors could help us determine the save percentage. And I did filter out all the original data set to include goalies that played in at least 10 or more games in the last NHL 2018-19 season to get a more accurate picture of their play. And so the regression output doesn't really reveal too much, as all three types of save percentages, so low, medium, and high danger save percentages, are statistically significant. So prior to looking at this model more in detail, I would like to explain what some of these terms do mean. So the image on the right is the offensive zone of an ice hockey rink in the NHL, and it does split up the offensive zone by the type of offensive zone area. So shots that are taken from this area are from the low danger zone, medium danger, and high danger. And to get a more accurate picture of the shot distribution, 44% of all shots are taken from the low danger zone, 32% from the medium danger, and 24% from the high danger. And obviously, as the distance does get farther away, the likelihood of the shot going in is lower, as we can see from the average save percentage. So from shots taken from the low danger area, 97.4% are saved, and the medium danger, 91% approximately are saved, but from the high danger zone, 79.82% are saved, which is quite low as compared to the other two. And if you think about this, this does reveal a flaw in the save percentage, which is an aggregate measure of all these, of all the three save percentages, which is that the save percentage as a measure doesn't adjust for the type of offensive zone shot. What I mean by this is that if you look at the coefficients of the regression model, the low danger shots against has a positive coefficient, which means that the more shots from the low danger zone a goalie faces, the higher their save percentage will get. And the high danger shots against, the coefficient for that is negative. So the more shots a goalie faces from the high danger offensive zone, the lower their save percentage will get. And to see how this can skew the save percentage, this shows the impact of low danger shots on save percentage, on the overall save percentage. So the more shots, proportionally speaking, that are a goalie faces from the low danger offensive zone, regardless of their what their high danger save percentage or medium danger save percentage may be, the overall save percentage seems to trend upwards. So as the proportion of shots from the low danger zone goes up, their save percentage is generally going up. And the more shots a goalie faces from the high danger zone, proportionally speaking, the lower their save percentage appears to be. So even if a goaltender has an above average high danger save percentage, if their defense isn't that good, and if their team defense isn't that good, and they're facing a larger proportion of shots from the high danger area, their overall save percentage will be lower. So finding out this kind of that save percentage may not be the most objective way to evaluate a goaltender's performance, I decided to look at another measure, which is goals saved above average. What this is we take the number of shots a goaltender has faced and multiply that by the league average save percentage. And that tells us how many goals a goaltender, an average quality league goaltender, would have allowed. We compare this against the number of goals a goaltender has actually allowed, and it kind of creates a plus minus measure, where a positive goal saved above average represents the number of goals that a goalie has prevented or saved above a league average goaltender, and a negative goal saved above average means that a goalie has allowed more goals than a league average goaltender would. So I decided to run another regression model with the GSAA per 30 minutes. So goals saved above average it's an aggregate measure, so the more games and a goalie has played, the more shots they faced, the higher their GSA could potentially be. So the GSA 830, which was a response of the second model, kind of adjusts this because it just looks at the goal saved above average for a goaltender per 30 minutes of play. And this is just an alternate measure that may give us that gives us a bit more of a more of an accurate picture as compared to the save percentage. So findings: what makes a good goaltender? So the original regression we ran, we saw that the save percentage as a response featured that revealed that perhaps it wasn't the most objective measure of performance, as when all the types of save percentages were aggregated, the low danger save percentages was masking the impact of high danger save percentage. That's why breaking down a goaltender's overall save percentage by the type of shot can give us a better picture and of their performance and enable us to conduct a more thorough analysis. And so the regression model we ran with the goal saved above average per 30 minutes as a response. This was the regression model, and just to give an example of how accurate this is, based on the figures, the high danger, medium danger, and low danger save percentage of Matt Murray, the model would have predicted a GSA 30 of 0.36, while the actual GSA was 0.52, which is quite close. And now that we've covered all the models to predict the success for players at different positions, in the next video, the presenter will cover and talk about using player success to predict overall team success. Thank you for listening.